There are two popular algorithms for searching arrays. And I know there's a lot more algorithms, but we're just going to talk about the two, these two. So two popular algorithms. The first is called a linear search. And this is also called a sequential search. So sequential search. And the second is called a binary search. So we're going to talk about the linear search first because it's simpler than the binary search, and then we'll talk about the binary search. So the sequential search steps through the array sequentially and compares each value. So we'd use some sort of loop to step through the array sequentially. So we're just going to start at the first value, compare the value that we're looking for with each value in the array, and the loop is going to stop when it gets to the value that we're looking for or it gets to the end of the array. So let's list some benefits and disadvantages of using this linear search. Because this is really, when it comes down to deciding what algorithms to use, or in this case, what type of search to use to go through your array, there's a lot of different ways you can do it. And like anything in life, everything has some advantage and some disadvantage. There's never like the perfect solution. So it's important to know what the disadvantages are, so when you're writing your code, or what the benefits are, so when you're writing your code, you know which one is going to be a better pick. So one advantage is that it's inefficient. And it's inefficient because it does look at every single value in the array. And by inefficient, we mean that it's slow. So the thing, like what we're looking at, like the types of programs we're writing in this class, this almost doesn't even matter because we're not dealing with really large arrays. But if you think about, say, Google search, I mean, no one wants to spend 3 days waiting for Google search to do their entire search for whatever they're looking for. So I can guarantee Google isn't using a linear search. And I don't know what their search algorithm is, but it's definitely not a linear search because it would be way too slow. Because you look at how many values they're looking at. So it's an easy algorithm. I mean, just based on what I've told you now, you could probably write this. You could probably write a linear search loop and just implement it based on what, like I wouldn't really need to show you the code. I think it's pretty, we're going to look at the code, but I think it's pretty easy to understand compared to some of the other searching algorithms. So so as far as the disadvantages, so it's inefficient, slow. It's going to read the array. So if it's going through everything in the array, that means that it's going to compare or read the number of values in the array as what the length of the array is. So this is going to read the array, a maximum. So read array, a maximum of n times, and n is just the length of the array. And then the average number of times that the linear search is going to read your array is n divided by 2. So for average, that's going to be about half of the array. So probably about half the time it's going to find the value in the first half of the array. It's going to end when it finds the value. Probably about half the time it's going to find the value in the second half of the array. So average is going to read the array about n over 2 times. So read over n over 2 times on average. And going back over to the benefits, one other benefit of this particular algorithm is because we are stepping through the array sequentially, the array can be in any order. Like, it doesn't matter what order the array's in, because we're looking at every value. Since we're stepping through the array in order and looking at every value, it doesn't matter where the value is, we're going to find it. The search we're going to talk about next, the array has to be in order and to find the value. So another benefit is the array can be in any order. So really with a linear search, it's good to use if you have something really short that you're searching, because it's going to be fast enough. I mean, for what we're doing, it's still going to be searching through our array in like a fraction of a second. If you have an array that's really large, and by large I mean like millions of values, or if speed is important for whatever you're writing, then you probably don't want to use a linear search. So I'm just going to put that the linear search should not be used with large arrays or where you care about speed. All right, so now let's talk about the binary search. So with the binary search, I've already mentioned that the array has to be in order. And so I'm just going to put that. The array has to be in order. So we can already see that one of the disadvantages, so array has to be in order. We can already see that one of the disadvantages of the binary search is if our array isn't in order, we're going to have to do a search algorithm and put it in order before we can use the binary search. So that's going to take computing power as well and memory. And plus we'll need to look at the array to see if it is in order before we run the binary search. If we don't know if it's in order. If you're using data that you know is in order, then this won't matter. But if you don't know if the array is in order, you'll have to check to see if it's in order first, which might almost involve a search within itself. But the way the binary search works is I'm going to just step through this algorithm. So let's say that we have an array, and let's say that it has 8 elements. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So what we're going to do, and let's say that these are in order, so we might have some numbers or data in this array that's in order. Let's just write some numbers. So let's say this is 10, 25, 30, 50, 80, 90, 100, 102, and 104. So let's just say we have this array, it has this data in it, it's in order. What we're going to do is divide the array into 3 sections. So we're going to divide, I'm going to move this down, divide array into 3 sections. So we're going to have a middle section, and the middle section is going to be equal to the first element plus the last element. So like the first element in this particular array at this point in time is 0, and then n minus 1. And n is 8 because we have 8 elements. So the middle is going to be the first element plus the last element divided by 2. And so that's going to be one section. The second section is going to be the elements to, well, let me just write on here. So let's just say the next section is going to be the elements to the left of the middle. So the middle is going to comprise of one element, whatever this is. So this is 0 plus, n minus 1. So 0 plus 7 divided by 2. So this is 3. So for this particular array, this is going to be our middle element. So the next section that we're going to consider is the elements that are to the left of that section. So elements to left of middle. And then the next section after that, so basically a third section, is going to be the elements to the right of the middle. And it seems like the middle should be 4. Oh, it's because this is 9 elements. Yeah, that's right. So this is 8. So this is 4. So our middle, I thought something looked odd. So the middle is right here. And then this is, so this is the first section here. The second section is here. And then this is the middle. Okay, so we have our array split into 3 sections. The middle section is only 1 element. Now what we're going to do is we're going to compare the value that we're looking for. So let's say the value that we're looking for is 107, just to pick a target value. So what we're going to do is compare what we're looking for, which is 107, to the middle element. And well, actually, let's say we're looking for 107, but first let's say we're looking for 89. 89 is the middle element. So if we're looking for 89, and let's say that we split up our array into these 3 sections, and then we say if the middle element is equal to the value that we're looking for, which in this case, if we're looking for 89, that would be true. So we found it. So then we're done because we found it. So let's write that down. So if the middle element, and I'm just writing some pseudocode, so this isn't like going to be actual code, but if the middle is equal to the value we are looking for, then we're done. But then what if, so that's if we're looking for 89. What if we're looking for 107? So if we're looking for, say, 107, this if statement will be false, right? So then what we're going to do is we're going to say if the middle element is greater than the value we're looking for. So in other words, if 89 is greater than the value we're looking for, then we're going to split our array again. Let me redraw. Let's see. So if the middle is greater than the value we're looking for, then we know that 89, so we're going to do this if statement. So if middle is greater than the value we're looking for, so if 89 is greater than the value we're looking for, we know that our value has to be somewhere in this part of the array. Whereas if middle is less than the value we are looking for, so if middle is less than the value we're looking for, we know that our value has to be somewhere in this part of the array. So now we've kind of split our array in half, so we know that the value is either going to be in the first half of the array or the second half of the array. So once we figure out which part of the array the value is in, like if it's in the first half or if it's in the second half, we can basically split our array in half. So if middle is greater than the value we're looking for, we're going to set last equal to middle minus 1. So we have middle right here. And if we know the value is somewhere in the first half of the array, so in this half of the array, we're going to reset our array so the first is still the same, but last is going to be middle minus 1. So we've basically split the array in half, and now we know the value is somewhere in this half of the array. So let's say that middle is less than the value we're looking for, then we know that our value is somewhere in the upper half of the array. So if that's the case, then we're going to split the array so we just have this upper half, and this last element is still going to be last, but then we're going to say that first is equal to, and I'll write this down here. So first is equal to middle plus 1. Then we're just going to repeat this. So we're looking for, let's say we're looking for 107. 107 is in this part of the array, so the upper half of the array. So we're going to split the array in half again. Right now, middle is equal to 4. So if the value is greater than, let's see, so 107 is, currently middle is less than the value we're looking for because middle is less than 107. So we're going to end up running this if statement. So now first is going to be 5. So first is now equal to 5. Last is still equal to 8. So if we go back up here and rerun our algorithm, middle is now equal to, well, first plus last divided by 2. So middle, 8 plus 5 divided by 2, so that's 6. So now our middle is 6. So now our middle is right here. And if we run this again, it's going to go through. 100 still isn't what we're looking for if we're looking for 107. So it's going to go through this again. It's going to find that our value is still in the upper half of the array. So we're going to split it again. So we're going to have this for our upper half. This will be our lower half. And we're going to calculate the middle again for the third time, which is going to be right there, and then we're going to find the match. So this time it took, what, like 3 tries to find our value, whereas with the linear search, we would have had to go through this. So 1, 2, 3, 4, 5, 6, 7. It would have taken 8 iterations to find our match with the linear search. With the binary search, it took 3. So the binary search is really, it can really cut down your search time. The problem with it is your array needs to be in order. So now let's go through and let's do the same thing we did with the linear search. Let's just list the advantages and disadvantages for the binary search. So disadvantages, and we're still talking about the binary search. So advantages, disadvantages. So one advantage is that it's more efficient when compared to the linear search. So compared to, linear search. It's going to be a disadvantage that the array elements need to be in order. I think those are mainly the advantages and disadvantages. You can calculate the max number of comparisons. So with the linear search, remember the max number of comparisons was just the length of the array, right? With this one, the max number of comparisons is determined by a power of 2. This is why it's called a binary search. So for instance, if we have, 2 to the 10 is equal to 1024. This means that the maximum comparisons for a 1,000 element array will be 10. So max comparisons for 1,000 elements will be 10. All right, so 65,536. So this means that the maximum number of comparisons in an array with about 50,000 elements will be 16. That's pretty amazing if you think about it. Like if we have an array with 50,000 elements and we only need to do 16 comparisons to find our match, that's pretty incredible.